Hey everybody, in this video we are looking at example 2 in the Polynomial Inequalities section. For a full breakdown of this technique, the strategy, the approach, watch the example 1 video. I'm going to kind of cut to the chase and get right to it. So what we want to do is we want to get our inequality to have 0 on one side before we do anything else. So x cubed plus x squared minus 4x minus 4 is less than or equal to 0. Now, if I had like terms, obviously I would combine them and keep it in standard form. Now I am going to kind of pay attention, notice, realize what is it I'm actually working with. It is a polynomial, specifically a cubic polynomial, and it's positive. That tells me the shape is going to look something along the lines of this over here, right? But, you know, I need to know more specifically. Why, you may ask? Well, if I want to know when is it less than or greater than or anything related to 0, I essentially want to know when is it either above 0 or I want to know when is it below 0. And we figure that out by finding the x-intercepts, which are your border patrol. That's how we get from positive to negative, and those are the only places we can cross this border. Got it? So how do we get our border control locations? We solve for the x-intercepts. So I'm going to factor this by grouping the GCF of the first two. If you need help factoring by grouping, please go to my factoring playlist and watch that video. So I'm going to be less descriptive. Just you have to help yourself and go watch it if you can't do this quickly. So x squared, x plus 1, minus 4, x plus 1. I'm going to write less than or equal to 0, but you'll see about that later. Then in the next step, I pull x plus 1 out front because that's my GCF now. If you are of the habit of writing x squared minus 4 in front next, I kind of think you don't really understand what you're doing. You're kind of just memorizing what you're doing. But to each their own. And then x squared minus 4, I'm going to factor right away to x plus 2 and x minus 2. That's the difference of two squares. I still want to know when it's less than or equal to 0. I'm going to get my x-intercepts. They will be negative 1, negative 2, and 2. I like to list them separately, specifically because I like to label my local behavior right underneath each one. So they're all to the first power. Your local behavior comes from your multiplicity of the factor from which your x-intercept came from. They're all first power, so that means locally they all behave like a linear equation, so that means at the x-intercept. My end behavior is how are the far ends of my graph behaving. It's positive and it's to an odd power, so that positive graphs point up on the right, and odd degree polynomial graphs are pointing in opposite directions on both sides. So it's my end behavior. Then I'm going to go over here and draw myself a cute little number line, and I'm going to plot tick marks for the three numbers that I am dealing with. So negative 2, negative 1, and 2. You don't really have to be to scale. We're good to go. So those are my x-intercepts. My graph is pointing up on the right, and they're all linear. So as I get to each one, linear means I slice through, but polynomials are smooth and continuous, so don't make any sharp edges. I got to turn around. Got to get over here, and locally, again, linear. I'm going to go pretty much straight through, and then smooth, turn around, linear again. And my end behavior is indeed correct. That's a good check that you are doing this correctly. And that is my graph. Now, to answer the main question that we're being asked. And what is it we're being asked? We're being asked, when is this less than or equal to 0? Less than or equal to 0? That's looking at the parts below the x-axis. So specifically, we're looking at this, and we're looking at this right here. So then we can go ahead and write down our answer. Hopefully everyone has followed. Our answer in interval notation from left to right, like writing a domain, is going to be from negative infinity until negative 2. This time I'm using a bracket, again, because it's or equal to. U for the union symbol, so it could be there, or we can look at negative 1 until 2, both with brackets. And that is the end of my solution interval interval sets or interval notation final answer. If indeed you need it on a number line, basically your number line that's going to be shaded is going to look like shaded there and shaded there. So if you want it to look a little neater, I mean, I guess, but I think this is a little redundant. I think what I did is A little better than a number line if you ask me, but if you want to know, your number line might look something like this. And if you had tested intervals in that garbage way, in my opinion, humble opinion, if you tested intervals, you would have gotten positive, and negative. But I had a lot of students that just get in the habit of thinking it alternates. Hopefully we all know, based on your multiplicity, your local behavior could be even or quadratic. And in that case, you would have not alternating signs. You'd have above, below, below again, something like that. So there you go. That's the end of the video. If you can give it a thumbs up when you appreciate, and if you want to give it a thumbs down because you hate, go right ahead. Questions, comments, concerns, requests, feedback, go in the description box below. I'll get an alert. And check the playlist that I'm putting together for this topic now, or check the description box. And every video I upload, I kind of increase that length of that description box until I go back and update all of them. And that's it for now. Adios.